Why are hypervelocity impacts a space threat? Have you ever wondered what happens when objects collide in space at extremely high speeds? This is a real concern, especially when we talk about hypervelocity impacts. These impacts occur when objects collide at speeds of several kilometers per second. In the vastness of space, this is quite common due to the high orbital velocities of satellites, meteoroids, and space debris. The danger of hypervelocity impacts is significant for spacecraft and satellite systems. The kinetic energy involved in these collisions is enormous. This means that the damage caused is far greater than what we would expect from slower collisions. When an object strikes another at hypervelocity, the materials behave differently than they would at lower speeds. The energy from the impact can cause local melting, liquefaction, and even vaporization of both the impacting object and the spacecraft surface. This results in craters and perforations, and it generates debris clouds that can pose further risks to nearby spacecraft. Additionally, the impact can create plasma, which is an ionized gas. This plasma can emit radio frequency signals that disrupt spacecraft electronics, leading to potential system failures or anomalies. The situation is made worse by the increasing amount of orbital debris. This debris includes fragments from defunct satellites, spent rocket stages, and remnants from previous collisions. These pieces travel at hypervelocity speeds as well. Even tiny particles can inflict serious damage due to their high kinetic energy. Spacecraft structures are often made with lightweight materials and complex designs, which makes them particularly vulnerable to these impacts. Detecting and locating impacts is also a challenge. The stress waves from impacts propagate through spacecraft structures in complex ways, making it hard to assess damage immediately. To mitigate the risks associated with hypervelocity impacts, engineers design spacecraft with protective shielding. One effective method is the use of Whipple shields, which consist of multiple layers that absorb and disperse impact energy. Monitoring and tracking space debris is also essential for collision avoidance maneuvers. Research into impact physics and plasma generation helps improve spacecraft materials and electronics. This research aims to make them more resilient to the effects of hypervelocity impacts. In summary, hypervelocity impacts pose a serious threat to space operations. They can cause structural damage, generate secondary debris, and disrupt spacecraft electronics. Addressing this threat is vital for the safety and functionality of satellites and other space assets. Understanding and managing these risks is a key part of ensuring sustainability in orbital dynamics.